Hi, can you hear me? Okay. So we'll start in a minute. But do you have any questions?
Professor?
Yes.
We got a message over the weekend that in order for our scores on tonight's test to be recorded properly, we need to be listed in the all sections site under our one section.
Uh-huh.
But currently we're all listed in sections 1 through 3.
Yeah, that's fine. That's fine. So I teach. So you this particular class is for sections 1 to 3. So that's okay. Yeah. So right now, all the students are from sections 1 to 3. So it's just for people to make sure that I have the grades. So so if you are listed in 1 to 3, I'll have the grades. So that's okay.
Okay. Thank you.
Yeah. Okay, so you seem to have a lot of questions. Okay, so formula sheets. Yeah, so in the formula sheet, you can write, I mean, formula, whatever stuff, some notes that you would want to refer to, right? It's something that you would want on your sheet. Okay. No, exam is still 13.1. We didn't even start 13.2. Yeah. About scanning, I don't know what you mean. Can you set the frame to upright? Right, how much time will you have to submit your answers? So the exam is supposedly should be for 30 to 35 minutes, and the rest of the time essentially is so that you will be able to submit the answers, I guess. How many questions? Maybe 5. So it would be more. I mean, I still didn't see the exam. Like 5 to 6 with some objective questions and like. So you have to answer them, give the answers on the quiz, and then maybe show some work on the handwritten stuff. So I still don't have access to the exam, so I don't know how it looks. Practice exam. So what do you mean by the practice exam? The quiz on the all sections, or the quizzes on the on our Canvas site? Oh, the review. Okay, so I don't have the solutions written down, but okay, if you guys want specific solutions, you can email me. We can discuss. Or I have office hours today, so I'll have office hours from 2 to 3:30, or maybe longer if people come. So we can discuss if you have any questions. Okay, so if you have any questions about some specific solutions or anything that you want, please come and see me in the office hours today. Okay, so after 2 to whenever till whatever time that you guys want. Okay, so we'll start at 2. No, it's still 13.1. We didn't start 13.2. We'll do 13.2 today. Okay. Any other questions?
Professor, I have a question.
Yeah.
So, like when you submit the handwritten part, do you have to submit your paper like within the duration of the quiz, or do you have to, like it's okay for you to run out of time in the quiz and then go submit?
No. It should be, the whole thing should be during the time, right?
So it's within the quiz duration.
Okay, so the quiz and the assignment. So there's a difference. So I don't know what you mean. The quiz and assignment have different entities. So both of them have different. Probably they're set to the same times. But if assignment might have slightly more time, if like say maybe 5 minutes more. You got what I'm saying? Just like the practice quiz that you've done. So the quiz is a one entity that you need to submit, and then there's an assignment portion that you need to submit. I'm not sure if maybe the assignment might have like slightly more, like not so much more gap, but you might have slightly more, like few minutes more for to submit the assignment. But yeah,
All right,
but
thank you.
essentially, don't count on it, but just think of it as the quiz time.
All right, thank you.
12.6, yes, officially it's, but 12.6, as I said, it's really about your visualizing ability. So given an equation, do you know how the surface looks? So that's all you need to know. So I mean, there's nothing much from that section. So if you have an equation, can you relate it to the surface that it looks like? Yeah, so okay, so there, yeah. So you have some more time after the quiz has some time slot, and there's that assignment that has a time slot. So you should make sure that after the quiz you should submit the assignment within the time slot of the assignment. Okay, so what else? I'm not outside. Yeah, so once the proctor track works till like the quiz time. So once you submit the quiz, you can then use your phones to scan or your handwritten stuff and then send the solutions. Is that clear? So the proctor track ends after you submit the quiz. So I can't say that, but so you would not expect too much graphing, I guess. Oh, okay, yeah. The good. The quiz is due 10:25, and the submission is probably okay. 10:35. Okay. Yeah. Other questions?
So do we have to record the scanning stuff? Like, do we have to use our phones to scan the answers while the camera is on?
While the camera is on, no.
So we have to submit the quiz first and
Yeah.
then scan and submit the assignment.
Yeah. So once you're done with the quiz, and you can then scan the assignment and send it. Yeah.
Okay, thank you.
Okay. Okay. So okay, I hope you guys. So it's slightly the first exam, so it's going to be you guys have, and it's a new kind of system. We are working on it. So yeah. So if you have any kind of troubles, just send me an email. So during the test, I'll be on email. You can email me, or send me an email if you have some questions. Yeah, the office hours are from 2 to 3:30. I mean, I can stay for longer if more people come. So if you have any questions, please come and visit me between after 2. Okay. Any other questions? Yes. Once you submit the quiz, the proctor track ends, and then you can upload your answers. Yeah. So the proctor track is the one that tracks your so kind of. If you are moving and stuff, that's the one that tracks. But once you're done, you can use your phones and take pictures and send the assignment. Okay.
Wait, yes.
Okay. So, question?
Hello.
Sorry,
Yeah.
I can't hear you.
Yeah.
Yeah.
So when I took the quiz yesterday, the practice quiz, after I submitted it, it didn't take me to the end screen. It just stayed there. So what do I do after that? Do I close the tabs out?
Okay. So we'll discuss it in some time. I don't exactly know what's happening. Okay. So yeah. Okay. Okay. So any other technical issues, please let's talk after the class. Okay. Anything else? Okay, so I have to go on, more on to the next lecture. So let's see, lecture 6. Okay, so the last section was, can you see the screen? Oh no. Okay, so 13.1 was the start of calculus. So we were trying to understand these functions. So if you have every t instead of just a function, now you have a vector valued function. So for every t there's a vector, and you want to understand how to do calculus on it. So how do you think of this function as just a particle that's moving, and at every point you are drawing a vector. The vector represents where the particle is. Okay, that's the picture. So you start for every time. So if you think of t as a time, then as time moves on, you're at a different position r of t, and you want to understand some features of this motion, like how there are different, a particle is moving, you want to understand different things about that particle. So certain things like velocity, acceleration, or what is speed, and the fact that the velocity is in the direction of the tangent. Okay, so these are three things that you need to know from this section. So let's, for instance, let's solve an example. Okay. So r of t is, say, sine t I bar plus t square j bar plus e to the x, sorry, e to the t k bar. Find velocity, acceleration, and the angle between them at, say, t equals 0. So what do you do if you want to find the velocity, acceleration, and the angle between those two vectors? Okay, so this stuff like this could be part of the exam as well. Okay, so let's see. So the velocity is nothing but the derivative of this vector, right? So would be cosine t I plus derivative of t is 1, so j plus exponential t k bar. Okay, so that means an acceleration is the second derivative, r double prime t, which is minus sine t plus the derivative of j, there's constant, so it's 0 plus e to the t k. So that's the acceleration. So velocity at t equals 0 is r prime at 0, which would be I plus j plus k. And similarly, acceleration at t equals 0 is r double prime at 0, which is just k. Questions? So you want to find velocity and acceleration, you just take the derivatives. First derivative is the velocity, and the second derivative is the acceleration. Sorry, what was the original? So it's sine t plus, okay, t. Oh, I thought it was, okay, so I was thinking it's t, so let's say t, okay. Sine ti plus t j bar plus exponential tk. Okay, sine t, t, and exponential t. Okay, so the derivative is cosine t, 1, and exponential t. The second derivative would be minus sine t, 0, and exponential t. Okay, so the velocity vector is this, acceleration vector is this. Now, can you tell me how do you find the angle between them? angle between them is, so we use this formula, right? Cosine theta is related to the dot product. Okay, so just cosine theta is nothing but a dot b over a times b. Okay, that's the, if you want to find the angle between two vectors a and b, this is what you would use, cosine theta. So in this case, so you want to take the dot product of 1, 1, 1 and 0, 0, 1. So that's the acceleration vector. And the length of the norm of velocity is nothing but 1 squared plus 1 squared plus 1 squared. And the length of acceleration is just 1. Is that clear? So why is r double prime just k? Because I substitute, so this was r double prime, sine t exponential t, right? If you plug in 0, sine t is 0. So this term goes, so the only term that remains is exponential 0 times k, which is k. Okay, so let's see. So this is angle between them is cosine inverse of this. This is a cosine theta. So this is cosine inverse of this angle. So this is cosine inverse of, this is 1 over, this is square root 3. No, isn't it I plus k for v? No, right? So for v, it is, the function is cosine t plus j plus exponential tk. So when you plug in 0, you get I plus j plus k. Sorry, what was the function was sine t, t and exponential t. So we differentiate, you get cosine t, 1 and exponential t. Okay, so yeah, is that good? So you find the vectors by just differentiating, and then if you want to find the angle, this is just using your information that you have kind of learned in the previous section. So if you find the angle, so you use the dot products and the lengths of those vectors, the magnitude of those vectors, use them together in this formula to get the angle between the vectors. Okay, questions? Okay, so next, let's say you have find the equation of tangent at t equal to 0 for r of t equals, say, sine t I plus t squared j plus some other function t cubed k. Okay, so now you want to find the equation of the tangent at the time t equal to 0 for this particle. So what do I do?
Differentiate.
Okay, so we need a point. So to find the equation of the tangent is a line, right? So we need a point on the tangent line and the direction. So the direction of a tangent line. Okay, so for us to be able to find, so can you find a point? So what is the point that you're passing through? So the point is nothing but r at 0, right? So you want the tangent to pass through the point at r equal to 0, right? So r0 is the point that you want. So if you plug in, the point would be So that's 0, 0, 0. So it's just the 0 vector. And the direction is nothing but r prime at 0. So let's see this. So r prime at 0 is nothing but cosine ti plus 2tj plus 3t squared k. So which is at t equals 0. So this is just I. Yeah, so you'll use the t times the direction vector to get that. So once you have this, so the equation of the line so if is nothing but r, say this is another equation, so let's call it a or r. So p at t is nothing but the initial point. Initial point is 0 plus t times this direction vector. So that would be the equation of the line. If I write it in coordinates, it's nothing but x equals 0 plus t times 1, y equals 0 times t times 0, z equals 0 plus t times 0. So that's basically x equals t, y equals 0, and z equals 0. So that gives you the equation of the line. Questions on this? So the initial point is 0 vector, 0, 0, 0. The direction is 1, 0, 0. So this is nothing but 1, 0, 0. So using that information, so you get this as the equation. X equals 0 plus t times 1, y equals 0 plus t times 0, and z equals 0 plus t times 0. Okay, so that's how you write the equation of the line. Questions on this? So once you have a point and a direction, we can use, so this basically, this is the equation. This is the point here, and then this is the direction. And if you write it in coordinates, you have 3 equations corresponding to 1 vector equation. Okay, so you can use, I mean, if you want, instead of t, you can make it some other letter if you want, but yeah, so if you can call it tau or something that looks like t, if you don't want to confuse, but. What, hy, is it 1 for x and 0 for, what is hy, sorry? Why is it 1? Oh, so this is the vector, right? So the direction is 1, 0, 0. So the velocity vector is 1, 0, 0. So the velocity in the x direction is 1. So that's why x starts with 0 and the velocity is 1, so 1 times t. Okay. Questions on this? Again, so all you need to know is you need to know what velocity is, acceleration is, and you need to know the fact that velocity is perpendicular, sorry, is tangent to the particle motion. Oh, if I didn't pick 0 as a point, so let's take, yeah, so say r prime t, say let's say it's t squared I plus exponential tj plus sine t k. Okay, so this is the thing. So let's try to find tangent at r at t equals pi or pi over 2. Okay, so let's see that. So the point is nothing but r prime at pi over 2, which is pi squared over 4 I plus exponential pi over 2 j plus sine pi over 2. Sine pi over 2 is just 1, so this is k. Okay, and the direction is r prime at pi over 2, So let's see what r prime is. So that's 2ti plus exponential tj plus cosine tk. So that's r prime. So if you plug in pi over 2, you get pi I plus exponential pi over 2j plus cosine pi over 2 is 0. Okay, so that's what you get. So from that, the equation would be, so this is called the parametric equation. So you can write it in the vector form or you can write it in the coordinates. So x0 is, so the point is pi squared over 4, exponential pi over 2 and 1. So xyz will be pi squared over 4 here, exponential pi over 2 here, 1 here, plus t times the velocity vector. So the velocity vector here is pi, exponential pi over 2 and 0. That's what you have. Okay. Is that clear? So you write your velocity vector, you write your point, and then using this, so both the information. So this is the point. These 3 coordinates are the point coordinates. These are the coordinates for the velocity. Okay, so this is the point and this is the velocity. Okay. Questions? Which one? So this is a point and this is the direction. Sorry, I don't have, okay, I can try to hold it like this. Can you see it now? Okay, so I'll move to the next topic. So, sorry, so we had to cover a lot of stuff. That's why I don't have time to just stick to the exam topics. So I have to move on. So, okay, so that's essentially 13.1. So those are the 2 kinds of ideas. So finding velocities, accelerations, and so on, finding tangents. Okay, so you should think of a particle motion, and this is the particle, and the velocity, velocity will be in this direction, right? So that's because if you subtract 2 nearby vectors, you get a vector in the direction of the tangent. Okay. So we have done something like this. So velocity, so the basic fact that you need to know is the velocity is the tangent direction. Because, so you need to know why that is true. If you try to subtract 2 nearby vectors, you get a vector in the tangent direction to the particle motion. So we should know why it's happening geometrically, and then you will be able to use it to compute some things like tangents. Okay, so next topic is 13.2, which is, so 13.1 was about derivatives, velocities, and so on. Now we move on to integrals. So can you tell me what this integral is? So there's no difference. We do it everything coordinate wise. So can you tell me what this integral is? Yeah. No, this is an indefinite integral, right? So this is not, first of all, it's related to the area of something, but it's not really area, right? So these are not numbers anymore. These are vectors. Right? So you just integrate by coordinate. So this would be just integral cosine t times I plus integral 1 times j plus integral minus 2t times k. Okay. So plus a constant vector. So instead of a constant number, now you have a constant vector. Okay, so So this would be, yeah, so you can, so those constants are not all the same. So that's why the constant here would be different, constant here would be different, constant here would be different. So you can write it as just one constant vector. All those two constants together can be written as one constant vector. So integral of cosine t is sine t, so times I bar. Integral of 1 is t j bar. Integral of -2 is minus t squared k bar plus some constant vector. So is that clear? Just there's no difference between your normal functions and this. You just do it coordinate wise. Integrate the stuff in front of I, integrate the stuff in front of j, and integrate the stuff in front of k. And the constants, each of them will give you different constants. Say here you get C1, C2, and C3. I can put all of them together as one vector. That's, say for instance, you can think of C bar as just C1, C2, C3. What dimension? So here it's 3, right? See, like I, j, and k. Oh, this is 13.2. Okay, so this is starting of 13.2, the integrals. The dimension C is just 3 coordinates, C1, C2, C3. That's coming from first constant here, second constant here, and third constant here. Okay, questions on this? Okay, so can you tell me what this is? Yeah, so these are you should think of it as 3 different problems. So let's see, you have some integral like this. Let me do it again. So this is nothing but should think of it as t square. So just think of them as numbers. You always have these vectors, but you have, so I split the integral into t square integral of 1 plus t squared j dt plus integral 1 over k, so 1 over t k dt, right? So just, there's no difference. So there's I, j, and k. They are not numbers, but they're vectors, but take them as just vectors. You can split them into these 3 parts. Now, the first integral is t squared. So it's t cubed over 3 times I bar. So you can think of I as just a symbol that you always have. Plus, but the thing is, you also need to include a constant, right? The integral of t squared is a constant. So the constant, so let me say it clearly. So this is nothing but integral t squared times I bar integral 1 over 1 plus t squared j bar integral 1 over t k bar. So now let's see what these are. So integral t squared is t cubed over 3 plus some constant. So let's call it C1 times I. Integral 1 over 1 plus t squared is tan inverse of t plus a C2 times j bar. And integral 1 over t is ln absolute value of t. Okay, times k bar. Sorry, plus C3, some constant. Okay, so that's it. So this is how you get your answer. So either you put 3 constants, a constant C1, C2, C3, or I can put all of them together and write as one vector. So this is t cubed over 3i tan inverse of t j ln t k plus C1 I, C2 j, and C3 k. If I bring out all those constants together. So, which is better to do the same thing, right? I mean, I can, whatever you prefer, it's the same thing. Whichever you find comfortable, you can do it. So this whole thing, you can just call it one constant vector. So instead of constant number, now it's this, I can just call it a constant vector, C bar. Okay, so you can just integrate normally and add a constant vector, or you can plug in 3 constants if you want. It's the same thing. So it's always like we're doing 3 things together. Okay, so whenever you have, so if you have vectors, it's in some sense it's we're doing 3 operations, 3 integrals, 3 derivatives, you have 3 constants. There will be 3 things together if you're doing it in 3 dimensions. Okay, so let's do one more. Can you tell me what this is? Now the integral is from 0 to pi. Yeah, so that's a vector. So in general, you'll have, when you solve for C, you'll have a vector equals this vector. So hence you'll be able to find all the 3 C's. If you have the C vector equals some other vector, then you can match coordinates and you'll get what the C is, right? Okay, so can you tell me what this integral is? Yeah, it's the same thing. Now just integrate sine ti plus 1. So this is tj minus t square k. That's the integral, right? And you do it from 0 to pi. Now you don't need constants here, right? You just, this is a definite integral. So you write this and you take it from 0 to pi. So now can you tell me what this is? Sine 0 minus sine pi minus sine 0, that is 0 I bar, plus pi minus 0 j bar minus pi squared k bar. Okay, so that's pi j bar plus minus pi squared k bar. Okay, so integrate first and then you plug in this boundary conditions or these values 0 and pi. Okay, is that clear? So it's just like what you do for normal functions. So so somehow we are doing it 3 times, or we have this I, j and k always that we need to keep track of. But if you forget about them, everything else is just like normal integrals and normal derivatives and so on. Okay, so let me so let's see. So there's some problem here. Let's try to solve this. So the problem is that there's a particle, so some glider which is accelerating with this. The acceleration is given by this quantity, and it started at a position 400 with velocity 3j. So velocity vector is given by 3j. Now you want to find what is the particle at any time. Is the question clear? So you know the acceleration of the particle, you know the initial velocity of the particle, you know the initial position of the particle. Now you want to find the position of the particle at any time. Do you know how you can do this? So you might have done some stuff like this if they were not vectors, right? So have you solved problems like this? If you know velocity and acceleration, how do I find the position at any time? Yeah, so it's the same, like instead of now, yeah, exactly. So whatever you have done with normal functions, you do the same thing with the vectors. Instead of thinking of them as numbers, now you think of them as vectors. That's it. So let's see. So what do you mean by, so R is what you want to find. So we want to find this. We want this R of t, right? So we are given R prime of so r prime of t is the velocity. So we are given the acceleration. R double prime is nothing but this acceleration that's already given. And we are given r prime at 0, which is 3j. Okay, so what do I do? So r double prime equals minus 3 cosine t I minus 3 sine t j plus 2k. Can you tell me what r prime is? So I know the derivative. Can you tell me what r prime is? Right? It will be the integral. So, right, so the derivative of r prime is known. So r prime of t would be just the integral. So this is say, okay, so let me erase this. If I integrate r double prime, you will get r prime at t minus, say, from 0 to t. So you get 0 to t of r double prime is r prime of t minus r prime at 0, which is of a of t. So let's find what that is. So this 0 to t, the integral would be minus 3 sine t plus 3 cos t plus 2t from 0 to t. Okay. So let's see. So this is nothing but minus 3 sine t. So this is I bar. This is j bar. This is k bar. So 3 sine t I plus 3 cos t minus 1 times j plus 2t minus 0. So 2t k bar. So that's the velocity. Okay, so that's the velocity at any time. So now what do you do to get? So that means r prime of t is r prime 0, which is 3j. So if so 3j plus minus 3 sine t I plus 3 cosine t minus 1 j plus 2t k bar. So that's the velocity. So we have determined the velocity. So how did you get the j vector? So what do you mean this 3j? You're saying this? Oh, I'm just integrating this expression. So minus 3 sine t, 3 cosine t, 2t. So if you integrate, you get 3 sine t minus 3 sine 0. So that is 3 sine t. Similarly, 3 cosine t minus 3 cosine 0, which is, oh, minus 3. Okay. Sorry, that's minus 3. Okay. So why did I use the bonds t to 0? Right? I mean, if I use the bonds t to 0, I'll get r prime t minus r prime 0. Okay, let me do it in a. Okay, so I had r double prime t was minus 3 sine t I minus 3 cos t j plus what did I have? 2k. Right, so this is what I have, and I'm saying this integrate this. So if I integrate r double prime t, you get this minus 3 sine t I minus 3 cos t j plus 2k, right, dt. So integrate this expression on both sides. Now you take it from, you can plug in some value. So I'll try to plug in from 0 to t, integrate it from 0 to t. Okay, so now let's see. So if I integrate r double prime from 0 to t, you get r prime at t minus r prime at 0. And the other side, you get minus 3, sorry, plus 3 cosine t I minus 3 cosine t minus 3j plus 2t k. Wait, something was wrong. So this was cosine t and that was sine t. Okay, this was cosine t and this was sine t. Okay, so let me write it again. Is that clear? So I have r double prime, I'm just integrating it on both sides from 0 to t. So you get minus 3 sine t I plus 3 cos t minus 3j plus 2t k if I integrate. And r prime at 0 is given to be 3j, right? So if I plug that information in, I get r prime t equals minus 3 sine t I plus 3 cos tj plus 2t k bar. Okay, so is that clear? So you have r double prime, integrate it from 0 to t, you'll get r prime. So now again, I want to integrate this from 0 to t of r prime. So I want so that I'll get r. So if I do that, so I'll get 3 cosine t plus 3 sine t plus t squared k at 0 to k t, so which is 3 cos t minus 3 I plus 3 sine t j plus t squared k. Okay, so that's what you get. So which is nothing but r at t minus r at 0. Oh yeah. So you need to, either you can integrate, so you can do the indefinite integral and solve for the constants, or you can just integrate it from 0 to t without and write it like this. Okay, whichever you prefer. If I do it this way, I don't need to worry about the constants. I do it like this, then this side would be r prime minus r prime at 0, and then you will get an expression. If I do it just with indefinite integrals, I have to plug in the initial conditions to find the constants. Whichever you prefer, it's the same thing. Yeah, the same thing. If you're given speed at 1, you integrate from 1 to t. Okay. So this is r of t minus r of 0. So let's see what happens. So r of 0 was given to be the vector 4, 0, 0. So that means this is r of t minus 4, 0, 0 is nothing but 4i. Okay. So let's put all of them together. So r of t minus 4i is this vector. So that implies that so r of t would be, you can solve what r of t is. So it's nothing but 3 cosine t plus 1 times I plus 3 sine t j plus t squared k. So that's what you get if I integrate. So essentially you are integrating it twice. To get from velocity to acceleration to velocity, you integrate once. To get from velocity to position, you integrate another time. Okay, so is that clear? So r double prime, if you integrate once, you'll get velocity, and r prime, you integrate another time, you'll get the position. Okay, so that's it. So that's all. Why did we subtract? Okay, again, so the integral is from 0 to t of r prime of t. So what is the integral from 0 to t of r prime? Right, so so I have r double prime of t is this acceleration vector, or r prime is velocity vector. So if I integrate it, I'll get this, right? But if I integrate it with specific bounds, 0 to t, so this side now would be integral from 0 to t of r double prime. So r double prime, the derivative is r prime, and you do it from 0 to t, right? Similarly, you have something from 0 to t. So this is nothing but r prime of t minus r prime of 0 equals whatever you get here. So is that clear? So if I integrate, you have r prime of t, and I have to do it from, but this is a definite integral, so it's from 0 to t. Okay, so this is one way to do it. Or if you want, you can just integrate and you have a constant, and you can substitute the initial conditions and find the constants if you want. That's a different way to do it, right? So for instance, here, instead of doing it like this, you know that r double prime of t is a of t. So that means r prime is nothing but integral a of t plus this constant that you get. So when you plug in, and you can plug in t equals 0 to get the constant. And then you get r of t equals whatever plus that constant that you get from here. Okay, these are the same. These are completely equivalent ways to do it, whichever you would prefer. Right? So you can integrate and determine the constant, or you can just integrate this equation like this, and you will get, you don't need to worry about the constants. You can directly manipulate that expression. Okay. So that's how you determine position of a particle if you know the acceleration and the initial velocity. So let's see. So we'll use that to do some solve some basic problems in physics. So if I throw a particle, so if I shoot something at a velocity, right? If I throw some particle, so what happens to the particle? So what is the shape in which the particle moves? Can you guys tell me? So if I just throw something up, say if I throw something up like this, right? What will happen to the particle? Right? So just whatever you have, just throw it like that. So what shape do you see? You can't see it here, but okay. If I throw something, maybe I have. Okay, so let's not try that. But if I try to throw something, what is the shape in which it travels? Okay. So it travels in a parabola, right? You might have seen this. If you throw anything in space, so it travels in this shape like this. Okay, this is a parabolic shape. Okay, so now you want to see why. So do you guys know why you get a parabola? So we'll discuss why we get a parabola, and so how do you solve this problem? So how do you determine the shape? Okay. So some basics. So if you imagine that you are throwing the particle with the initial velocity, that means initial velocity vector, which is v0. So that's the initial velocity vector. So you're throwing it at an angle. So imagine that your initial velocity is v0. Okay. So now I want to know what is the position of the particle at any time. Okay. What is this r? The position of the particle at any time. So that's what I want to determine. So let's see. So can you tell me what is the acceleration? So you have a particle, my initial velocity is v0. So can you tell me what is the acceleration? Okay, so the acceleration of a particle is given by minus g times j. So, okay, so is that clear? So let me, so we are calling this as, so if this is I, the direction of I, this is the direction of j, the acceleration is in this direction. So do you guys know that? The acceleration due to gravity is in this direction, minus j bar. Is this fact clear for you guys? This is a basic fact. So because the gravity is acting, is a force that acts towards the center of the earth, you'll see that the acceleration is something like this. It's towards, so if j is in the upward direction, so the acceleration is towards the downward direction. So it's, that's why is j times this g. G is this gravitational constant. It's acceleration due to gravity. Is that clear for everyone? Have you guys seen some physics? Okay. Okay, so the acceleration would be just in this direction with the magnitude of g. So that's why it is minus g times j bar. So I'm calling this as I, this as j, right? Now, so my initial velocity was v0. Okay, now I want to determine the particle position. So can you tell me what will be the velocity at any time? If I integrate this, what will be the velocity? So this is derivative of velocity equals minus g j bar, right? Acceleration is nothing but the derivative of the velocity, so which is minus g times j bar. So if I integrate this, integrate v prime, you get minus gt. The integral of this from 0 to t is minus, okay, g j bar dt, which is nothing but minus gt j bar. Okay, so this is the vector. Okay, and here this is from 0 to t. So this is nothing but v prime at t minus v prime at 0, which equals minus gt j bar. Okay, so that gives you v prime at 0 is not v prime at t is v prime at 0 plus, sorry, plus is here minus, so minus gt k bar j bar. And v prime at 0 is nothing but is given to be this vector v0. So you write it like that. Okay, so that's how, if you integrate once, if I know the acceleration, I'll be able to get the velocity. Now I want to get the position, right? So you integrate it another time. So if I integrate it another time, so v prime at t dt from 0 to t of integral of this v prime gt j bar dt from 0 to t. So I integrate this expression, I get this. So this is nothing but, if I integrate, sorry, this is I'm sorry. V prime, the integral is V, right? So this is V, this is V, this is V. I'm sorry. Yeah. So I'm thinking of R prime, but yeah. So if you write it in terms of V prime, yeah. So it's in terms of V, it's just V. I was thinking of, I thought it's R prime, but yeah. So integral of V prime is Vt minus V0. So that's why Vt equals this. So integral of Vt, but V is nothing but R prime. So Vt is nothing but R prime. So R prime. So this gives you R of t minus R of 0. If I integrate RT, and this is nothing but V, if you integrate, this is a vector constant times t minus integral of gt is half gt squared. Okay. So now R of t would be R of 0, so plus Vt velocity times t minus half gt squared times j bar. Okay, that's what you get. Oh shit. So R of t is nothing but R at 0 plus V initial velocity times t minus half gt squared times j bar. So have you guys seen expressions like this before? You might have seen it without these vectors, but now this should be adopted to the vectors. So all of them are vectors. R is a vector, V is a vector, and this j is a vector. Okay, so now let's use that to solve this problem. So is that clear? So all I'm saying is, in this case of the projectile, a particle moving in the gravity, it's like falling in the gravity, it's just, all you need to know is the acceleration. And this fact, the acceleration is minus g times j, is a physical fact, right? This comes from physics, right? Newton's laws, essentially. If you guys know some basic physics, the fact that acceleration is minus g is comes from Newton's laws. The force is minus mg in the direction of, so that's towards the earth, right? Okay, so now let's see. So can you tell me, so let's use that to solve this problem. So there's a projectile that's launched at 60 degrees and initial velocity is 500 meters per second. Can you tell me what is the position of the particle at 10 seconds? So what do I do? Okay, so you're firing something at 60-degree angle at 500 meters per second, and you want to know what does it look after 10 seconds. So what do I do to do this? Right? So we know from the previous stuff, you solved for the position with respect to the time. So we need to compute all these quantities, then you'll know what the position is. So R of t is R at 0 plus V0 at t minus half gt squared at j. Yeah, so what is the initial velocity? So you're starting from the origin, it says, so that means R of 0 is 0, right? The first information that you have, you're starting from the origin, so R at 0, the initial position is just 0. But what is the initial velocity? What is the initial velocity? No, I want the vector. The magnitude of the initial velocity is 500, but what is the vector? So I want a vector whose magnitude is 500, and this is 60 degrees. So what would be the vector? So can you tell me what are the coordinates of that vector? Yes. So this is 500. So this is 500 cosine 60, and this is 500 sine 60, right? So the vector would be 500 cosine 60 is how much? A half, right? So 250. So this is 250i plus this is 250 square root 3j, right? Sine 60 square root 3 over 2. Okay, so just plug that information in. So this is nothing but 250i plus 250 square root 3j. So that's the initial velocity times t minus half gt squared j. Okay, so that's the position at any time. So if you plug in t equals 10 seconds, you'll get what you want. So if I plug in t equals 10 seconds, what do you get? So R of t turned out to be 250i plus 250 square root 3j. So this was the initial velocity times t minus half gt squared j, right? So this is what you have at any time. So if I plug in t equals 10, you get r at t after 10 seconds is nothing but 250 I plus 250 square root 3 j times 10 minus half g 10 squared times j. Okay, so if I compute this is approximately, so g is 9.8, right, meters per second. If I use that, this will turn out to be approximately this. So the j is 2500 I plus 3840 j. So just compute it. If you compute this quantity, you get this. Okay, now can you tell me what is the position of the particle? Okay, so the position is, so it is at a distance, a horizontal distance of 2500 meters and a height 3800 meters, right? That's what you have. So this is the x distance, this is the y distance, because if this is the position, that's a vector, so this gives you, x coordinate gives you the horizontal distance, y coordinate gives you the height. Oh, this is just simplify this. It's 250 square root 3 minus half gt square. If you compute this quantity, you'll get approximately something like this. You have to compute, multiply with square root 3, multiply this numbers. Okay. Questions on this? So let me say a few things basically. So this is called the motion that you see. So it's called it's a parabola because of this half gt squared, right? The function is something, it's a quadratic function. Okay, so if you write the position, you can just, if it's asked in terms of vectors, you can just write as a vector, or if they ask the x distance and the y distance, you have to write both x and y distance, height and the horizontal distance. So they can just ask you to leave it as a vector, or they can ask you what is the horizontal displacement and what is the height. So okay, so it depends on what they ask. But anyway, again, so we solved. So this is nothing. This is what our equation is. So let me. So I wrote r is nothing but v0, the vector t minus half gt squared j, and v0, if you want in terms of sine theta and cosine theta, you can write it as v cosine t v cosine alpha and v sine alpha, like we have done before in the example, right? If we don't know the vector would be, if it is v0 and the angle is alpha, the vector would be v0 cosine alpha times I, v0 sine alpha times j. So if you plug that in, so this is nothing but v0 cosine alpha and v0 sine alpha. If you plug that in, you'll get an expression like this. And so why is it a parabola? You can see that's a parabola because if this is x, this is y. The relation between x and y is a quadratic equation. Okay, so there's a t square, so there's a quadratic. So y as a function of x is a quadratic function, right? So for the quadratic functions, you see that. So how do quadratic functions look? They look like parabolas. So that's why you see a parabolic shape, right? If I try to write this y, the y distance in terms of the x, you'll see that it's a parabola. So it's so that's why it's a parabolic equation. And okay, anyway, so this motion, so that motion is called a projectile motion. So there's a general name for this parabolic path. And there are some parameters that you can derive from these. So so once you have this position at any time, you can ask for what is the maximum height, right? So this is the height as a function of time, right? This is the horizontal position at a function of time. This is the height as a function of time. So you can ask questions like, what is the maximum height? So you can differentiate and equate it to 0, and you see that this is the maximum height, right? Is that clear? So if I have, this is the height as a function of time, and you want to find the maximum height, you differentiate this and equate it to 0, you get the maximum height. So this is the maximum height. And you can ask, what is the time of the flight? That means that if you start off here, when does it come back here, right? So you can see that it comes back here when the y is 0, y becomes 0. So you can try to check when is the height becoming 0. At this time, the height becomes 0. So the height increases to a maximum height, and it becomes 0 after this much time. You can check. So the height is 0 at this particular time. So if you plug in this particular time, the height would be 0. So that's why after this much time, you will come back to the position you started with. And the range is this distance, the distance that you have traveled. So this is the flight time, and this is the horizontal velocity is v cosine alpha. So that's why this, if you multiply this with v cosine alpha, you'll get the range. Okay, so all of them can be derived. So if you know the position of the particle at any time, you can derive what is the maximum height. You can derive what time it takes to reach back to the ground, and you can also derive what is the horizontal distance that is traveling. Okay, so these are the 3 quantities. Just all of them can be derived just by looking at what is the position at any time. Any questions in this? Okay, if you don't need to remember these, if you know how to do it, all you need to know is that acceleration is minus g j bar, and everything follows. Or if you don't want to derive them, you can just use these formulas at any point. Okay. Yes, you can use them, but I'm saying, but you need to also understand where these equations are coming from, right? So, I mean, you can use them, but it's good to know where the equations are coming from. So you get this basic equation by integrating our acceleration. You start with acceleration, integrate it to get velocity, integrate the velocity to get acceleration. So you get the position at any time. Once you know the position at any time, you can determine so many things. You can determine the height, this time, and this range, the distance it travels. Okay, questions on this? Okay, so let me say some more aspects of a particle motion, for instance. So this, so the question is, you want to understand what is arc length. So if a particle is moving and along some path, you want to know what is the length of this path, right? what is the distance? You're traveling along this curved path and you want to know the distance you travel along that curved path. So how do I determine the distance? Okay, so if you start off at some time t0, the distance you travel along the curve is called the arc length of the curve. Okay, so it's the length along the arc. Okay, if you measure using a measuring tape as you move along the curve, how much from, say, if you started at time t0, if you move till time t, what would be the distance that you have traveled? Okay, so how do I compute the distance? So the distance is nothing but, say, if you want to compute the distance that you travel between some time t and t plus delta t. In a small amount of time, you want to compute the distance. So how do I compute the distance you travel in a small amount of time? Right, imagine that you're moving and in a small time dt, you want to find how much distance you traveled. So how can you find that? Right, if I know the speed at which I'm traveling, so you're not traveling at the uniform speed, your speed is varying. So if I want to know what is the distance I traveled in some small amount of time, if I know my speed at that time, I'll be able to find the distance. Is that clear? So this is the main idea. If I know my speed at some time, I can multiply that speed with the time elapsed to find the distance I traveled in that time. So if my speed at any point is not, so because my particle is r prime, r, so my velocity is r prime, so my speed is the magnitude of that velocity. So that is magnitude of that velocity is the speed. Times the time you travel for is dt, for small amount of time, dt say, so v times dt will give you the distance you traveled in the small amount of time. Okay. So, and you want the whole distance, you add up all those distances. If you start off at time A and to time B, if you want to add up all these distances, you'll get the total distance. So you add up the distance from here to here, distance from here to here, distance from here to here, distance from here to here. So you get the total distance. So that's why the arc length or the distance is nothing but the integral of v absolute values of, or the magnitude of v dt. Okay, that's the formula for the arc length from time A to time B. So is that clear? If I want to find the arc length from time A to time B, I have to integrate this absolute or the magnitude of v times dt. Is this clear? So this is the main idea. And then we know that v is nothing but x prime, y prime, and z prime, right? So the v vector is nothing but x prime, y prime, and z prime. So the absolute value of v is nothing but the square root of absolute value of v would be square root of x prime square plus y prime square plus z prime square. So geometrically, it's just the speed times the time is absolute values of the magnitude of v times dt. That's for small amount of time. You add them together, you get the total distance. But that's the same thing if you have x of t, y of t, and z of t. Absolute value of v is nothing but this. All right, because v is x prime, y prime, and z prime. So absolute value of v is x prime square plus y prime square plus z prime square. So the integral of it is. So you have this. So this is the formula for finding the arc length between time A and time B. Okay, so so we can use that to compute. So can you guys tell me what is the perimeter of the unit circle? So you want to compute, so the unit circle. So I want to know what is this length. Right? So can you tell me what this length is? If I move from here to here, I want to know what this length is. How much distance will I move? I'm moving along a circle. So what is the length that I travel? So from I start here and come back to the same position, how much distance I travel? 4 pi. Why is it 4 pi? It's just 2 pi, right? So I know that it's 2 pi. So how is it 2 pi? Can you guys tell me why is it 2 pi? So you might have learned in school and stuff that it is 2 pi, but do you know why it is 2 pi? Yeah, that's what people have told you, that is 2 pi always. Oh, 360 degrees. Okay. Yeah, you can think of it as okay, 360 degrees, yes. But so what is pi for you? It depends on what pi for you, right? Either you define, okay, there are two ways to think of pi. Either you think of pi, 2 pi or itself is the distance, then it's a definition, there is nothing new. If you're thinking of 2 pi itself as the distance, then there's nothing new, right? If you think of 2 pi as already as a distance on the circle, so pi for you is itself a distance on the circle. If that is the case, then this is automatically a definition. But let's say pi for you is the area of the circle. Okay, someone tells you that the area of circle is pi. Now you want to know what is the perimeter of the circle, right? So if area is pi, what is the perimeter of the circle? So somehow the perimeter would be 2 pi. So you want to understand what is the relation between the area and the perimeter. So let's see how you do this. So here r of t, so r of t at any place is nothing but cosine t and sine t, right? So this is the position, and time goes from 0 to 2 pi, right? You're moving from 0 to 2 pi. This is the r of t. So now let's compute this arc length by that formula is integral from 0 to 2 pi of x prime squared plus y prime squared dt, which is nothing but integral from 0 to 2 pi. X prime is cosine t prime, which is okay, so minus sine t squared plus sine t derivative is cosine t squared dt. Okay, so what is that integral? So you have integral of minus sine t squared plus cosine t squared, which is sine t squared plus cosine t squared, which is 1, right? Sine t squared plus cosine t squared is 1. So that's why the integral is nothing but 0 to 2 pi of 1 dt. So what is that? Right, this is x and this is y. I compute x prime, y prime, take the squares and add them up, take the square root, you get 1. So now integral from 0 to 2 pi of 1 is how much? It's just 2 pi, right? It's 0 to 2 pi of 1 is nothing but just 2 pi. Okay, so that's it. So that's why the arc length is 2 pi. So I mean, this is kind of showing you that the arc length formula works. Okay, so we'll discuss other stuff in the next class. So so good luck for your exam. So if you have any questions, come and meet me in the office hours at 2 o'clock.
Professor?
Yeah.
I just wanted to ask for the exam. For 12.6, are we supposed to know how to graph all those cones, hyperboloids and stuff, or like do we just need to know what the equations look like?
So it's, yeah, I mean, yeah, so the more important thing is to know, given the equation, like knowing how the shape would look like. Or both sides. So I mean, okay, you won't expect many questions in the exam, so but that section is, but you should know this thing is important. Yeah.
Okay.
Yeah,
thank you.
So yeah, just essentially if you practice a problem like so the first problem in the section, right? So just looking at the equation and seeing what kind of pictures you have.
Okay, thank you.
Yeah. Okay, so anyone who wants to talk to me, please hang around and we can discuss. Okay.